Hey guys, it's Mr. Fraser here from NeonMaths. Bright maths, bright future. How you doing? I hope you're well. I'm feeling pretty good. The reason I'm feeling pretty good is because today we're going to start with my favourite part of maths, and that's algebra. It's going to be a session. This is going to be the first session that we do on solving equations. So it'll be quite standard. It's a really good place to start if you've not done much solving equations before. But if you're an advanced student who is solving really complicated equations, well, those equations have their roots in what we're doing today. So it's important. It's really important. I blimmin' love algebra. Students always ask me, put their hands up, and "Sir, what's the point of algebra? When am I ever going to use this in real life?" And my standard answer is you might not, but who cares? Because it's fun.
Fractions when they come up with the root sign down. Lethal weapon in your mind, like a gun without a sound. No shortcut, no mark scheme, quit your chattering. It's your discipline, lets you stay true to your regimen.
Now, before we get our teeth stuck into solving linear equations, there are a few things that I need to remind you about. A plus B, that means the value of A plus the value of B. C minus D means we're taking the value of D away from the value of C. 3x means 3 multiplied by x. PQ, remember in between that P and that Q there's an invisible multiplication sign. When we've got two letters next to each other, all we need to remember is that we're multiplying those two values together. So we're doing P times Q. ABC similarly means A multiplied by B multiplied by C. E over M. We often write division in maths as a fraction. So E over M just means E divided by M, the value of E divided by the value of M. And B squared means B multiplied by B. Those are simple rules. You really need to make sure you're confident, you're happy with those, and you know when and how to apply them. Remember, an algebraic expression contains a combination of numbers, letters, and operations. For example, 2a plus 3b minus a plus b. That's an example of an algebraic expression. Notice there isn't an equal sign. We can't solve anything. It's not an equation. Now, we could write this more simply, and we've looked at that in a previous video, but we could write that as a plus 4b. Now, this is just what we call in maths an identity. We often use that to show that this and that are identical, and it's an identity. Now, an algebraic equation links an algebraic expression with a number or two algebraic expressions with each other using an equal sign. For example, this is an example of an algebraic equation. In an algebraic equation, the unknown has a very specific number, and finding out what that number is called solving the equation. Now, we can do that by looking at this and going, what number added to 7 has a result of 13? Well, 6 plus 7 equals 13, so we know that x, in this case, must be 6. Now that seems very straightforward, and with many questions like this, you can look at it and with a little bit of thinking, pop a number into your head and you'll be able to tell me what that unknown is. But as maths progresses and as the topics get more and more difficult, we need to be aware of a better way of doing that. And in order for us to be able to do that, we're going to learn about inverse operations. Okay, it sounds scary, but it just really means the opposite. Okay, we're going to be doing the opposite of what we've done. So, once again, you may be able to have a look at this question and just pop an answer into your head. What I'm going to be doing, you might be thinking, that's way too easy. I don't need to do those steps. But if you do those steps, if you learn the steps properly now and they're easy, then this will carry you on through all the way to solving much, much more complicated algebraic equations. Right, so what do I mean by inverse operations? Okay, we're going to have another look at this relatively easy question. Now, this is an example of a linear equation. Linear equations are probably the easiest to solve. And we know it's a linear equation because the highest power is 1, x to the power of 1. If it was x to the power of 2, it would be an example of a quadratic. If it was x to the power of 3, it would be a cubic. What we're going to be doing today is we're going to be focusing on how we solve linear equations using inverse operations. I've drawn a little function machine up here to remind me what it is. X goes in, we take away 2, and we get our solution of 3. Now, we need to be able to work this backwards. So we're doing the inverse operation. So we're starting with 3. The first thing that we're going to do is the opposite of taking away 2. So we're going to add 2. So our first step is to add 2 to both sides. I like to write it underneath just to show my working really clearly. Negative 2 or minus 2 plus 2 equals 0. That bit cancels out. Okay, leaves me with just x on the left hand side, and on the right hand side I have 3 plus 2, which is 5. Okay, again, you're probably saying, but I can do that without doing those steps. Remember, these steps are useful for when they come and they get a lot more difficult. Right, so here we have an example of a slightly more difficult equation, which we need to solve. Now, it's only more difficult because it's going to take us more than just one step. Again, you can look at that and you can strain for long enough and eventually you'll be able to tell me what the answer is, what x is. Okay, we're going to use inverse operations. I often think of these types of questions as like a big knot of string. Now, if you start untying the knot from the wrong place, you're just going to make it worse. What you need to do is you need to kind of do it in opposite order which it got to that point in the first place. So that's why a function machine is useful. Now, I wouldn't expect you to use a function machine for very long. Eventually, you're going to get the idea. We're kind of working backwards of BIDMaths or PIMDAS or BODMaths, whatever you use to help you with the order of operations. But again, a little function machine helps me. I start with x. First thing I do is I multiply it by 4. Then I add 5, and then I get 29. Now, in order for us to solve this, we need to work it backwards. We need to go the other direction. So we're doing the inverse operation. So the first thing I need to do is take away 5 from both sides. That leaves me with 4x on the left-hand side. 5 take away 5 cancels out. So we're left with 4x